So, you've done it. You've spent weeks, maybe even months, training a brilliant machine learning model. It's smart, it's accurate, but right now it's just sitting on your laptop. In this explainer, we are going to unlock its potential. We're going to turn that isolated file into a live, powerful application that anyone, anywhere can actually use.
And that's the million-dollar question, isn't it? A model is really just a file until it can interact with the real world. So how do we get it from your local computer into a tool that can make real-time decisions for a website, an app, or a business? Well, the answer lies in the world of APIs.
Our journey starts right here with this challenge, taking our model from its digital island and building a bridge to the rest of the world. And this bridge, it needs to be fast, it needs to be reliable, and it has to speak a universal language that any application can understand.
That bridge, it's called a REST API. You should think of it like a universal translator. Seriously. It doesn't matter if your app is written in JavaScript, Swift, or Python. The API creates a standard way for that app to send data to your model and get a prediction back. It is the absolute foundation of real-time machine learning out in the wild.
You know, the core loop is surprisingly simple. An application sends some data, let's say a customer's information, to a specific URL. The API catches that request, hands the data over to our model, and gets the prediction, like, is this customer going to churn? And then it sends that answer right back. This whole four-step dance happens in milliseconds, thousands of times a minute.
Okay, so we know what the bridge is, but now how do we actually build it? For that, we're going to need the right tools and a solid blueprint. So let's look at the most popular frameworks that developers are using to construct these powerful ML APIs.
For the longest time, Flask was the go-to. I mean, it's simple, it's flexible, and it is fantastic for learning. But the industry has been shifting. FastAPI is a newer, more modern framework built specifically for high performance. And its key advantage isn't just about speed, but all the developer-friendly features it includes right out of the box.
And this is a really key takeaway. While you can absolutely build a great API with Flask, the industry has pretty much voted for FastAPI. When you're dealing with production systems where speed and reliability are everything, FastAPI just has the edge. It's that simple.
High performance is a no-brainer, of course, but that automatic documentation, it's a total game changer. It literally creates an interactive web page where you can test your API right in the browser. Then you have asynchronous support, which means it can handle tons of requests at once without getting bogged down. And finally, that built-in data validation stops bad data from ever reaching your model in the first place. It is the complete package.
Okay, our API is built. It works perfectly on our machine. But that's not enough, right? We need to package it up so it can run reliably anywhere, on a coworker's laptop, a test server, or in the cloud. We have to make it portable.
And the answer to that is Docker. Honestly, the best metaphor for Docker is a standardized shipping container. You put your API, your model, your Python version, and all of its dependencies inside this one container. Now you can ship this container anywhere and you are guaranteed it will work exactly the same way. No more of those, well, it works on my machine problems.
The whole process is remarkably straightforward. First, you write a simple text file called a Docker file. Just think of it like a recipe that lists every ingredient and step needed to build your application's environment. Then you run one command to build your container image and a final command to run it. This three-step process is pretty much the gold standard for deploying modern applications.
So our API is now perfectly packaged in this portable container. But a container sitting on a hard drive isn't doing anybody any good. To make it globally accessible 24/7, we need to put it somewhere that's always on and always connected. We need to deploy it to the cloud.
And the major players, Amazon, Microsoft, and Google, all offer these powerful, specialized services just for running machine learning workloads. You don't have to manage servers yourself anymore. You just give them your Docker container, and they handle all the scaling, reliability, and infrastructure for you.
So we've launched. Our API is live in the cloud. Awesome. But what happens when it becomes a success? What happens when you go from 10 users to 10,000? Now we have to start thinking about making our service robust, secure, and ready for some serious traffic.
This is where the real engineering kicks in. We use something called a load balancer to spread requests out so no single server gets overwhelmed. We cache common predictions so we don't have to ask the model the same question over and over again. And we can use incredible tools like Kubernetes to automatically add more servers when traffic spikes and then remove them when it dies down. Following a checklist of best practices here is absolutely essential. Always preload your model when the API starts up, so that first user doesn't have to wait forever. Always use Docker. And maybe most importantly, implement logging and monitoring. You need to know if your API is slow or throwing errors before your users do.
We have gone through the whole journey, from a local file all the way to a globally scaled production-ready service. So now let's look at the payoff. What can this model, now that it's supercharged by an API, actually do for the world? This is where it all comes together. A bank can get an instant loan decision. Instead of a customer waiting days for approval, their application data gets sent to the API, the model returns a risk score in milliseconds, and a decision is made right there on the spot. That is a massive improvement in customer experience and efficiency, all powered by the exact architecture we just walked through.
And ultimately, that's the transformation we've just witnessed. We didn't just deploy a model. We created a live, intelligent decision-making engine that can be plugged into any system anywhere to make it smarter.
And this really says it all, doesn't it? The most sophisticated model in the world is completely useless if no one can access its predictions. APIs are what make machine learning accessible, and that is what makes them powerful.
So now the question goes right back to you. The tools are here, the blueprint is clear, you have a model that's ready to go to work. So what real-world problem are you going to solve with it?